So today we're gonna learn about indeterminate forms and using the L'Hopital's rule. So indeterminate forms refer to when a limit is approaching a value but there is no numerical value. So for instance, let's say we have the limit of approaching 4 for the function x squared minus 16 over x minus 4. So when you plug in 4, you end up getting 4 squared minus 16 over 4 over 4. So since 4 squared is 16, that's 16 minus 16, 0, over 4 minus 0. 4 minus 4, I mean, which ends up being 0 over 0. And this is an indeterminate form because there is no numerical value for this. Another example of an indeterminate form is for this example where the limit of x is approaching infinity for ln over x. And when you substitute in infinity, ln of infinity over infinity is the same as infinity over infinity, which is another indeterminate form. So there are more indeterminate forms. These are all the ones I have listed here. So I've already showed the example for 0 over 0, infinity over infinity. The reason infinity minus infinity is an indeterminate form is because infinity is not a number, so you cannot just subtract infinity from infinity since it is not a set number. The same apply to 1 to the power of infinity to the power of 0, and 0 times infinity, strictly due to the fact that infinity is not a number, so the form is indeterminate. Now, the reason why 0 to the power of 0 is an indeterminate form is because we'll see when 0 is raised to the power of anything, we end up getting 0. 0 squared, 0 times 0 is always 0, 0 times 0 is always 0, which means that 0 to the power of a is always equal to 0, except for when a equals 0. On the other hand, when you have any number raised to the power of 0, you always get 1. So 1 to the power of 0 is 1, 5 to the power of 0 is 1, and even 9.25 to the power of 0 is 1. So this indicates that b to the power of 0 is always 1, except for when b equals 0. So that shows why we cannot have 0 to the power of 0, because no matter what you multiply 0 by, you wouldn't get 1. Because whenever you multiply 0 by itself, you always get 0. However, the rule typically is when something to the power of 0, you get 1. That's why 0 to the power of 0 is an indeterminate form. Now, when you have an indeterminate form, you will be using L'Hopital's rule to actually evaluate the limit, because you cannot just leave the limit as an indeterminate form. The L'Hopital's rule is when you differentiate the numerator and the denominator and then evaluate the limit again. And if you would differentiate the numerator and the denominator separately, you do not take the closure. So for example, we have the limit of x is approaching 0 for sine of x over x. So when you evaluate this, you end up getting sine of 0 over 0. And sine of 0 is 0. The 0 over 0 is an indeterminate form, which means this is not how we can evaluate this limit. However, by using L'Hopital's rule, you can take you can differentiate the numerator and differentiate the denominator. So the derivative the derivative of sine of x is cosine of x, and the derivative of x is just 1. So you can rewrite this as the limit of x is approaching 0 for cosine of x over 1. And then the cosine of x, the cosine of 0 is 1. So when you evaluate that, again, you get 1 over 1, which is just 1. Another example for this is the limit of x is approaching infinity for x squared over e to the x. So when you evaluate this, you end up getting infinity squared over e to the power of infinity, which is the same as infinity over infinity. However, this is an indeterminate form, so we need to use L'Hopital's rule to re-evaluate the limit. So the derivative of x squared, you bring the 2 to the front using product rules, 2x as the derivative, and the derivative of e to the x is just e to the x. So you can rewrite your limit as x is approaching infinity for 2x over e to the x. And this does not look like e to the power of x, but it is. So when you reevaluate, you end up getting 2 times infinity over e to the power of infinity, which again is just infinity over because you can take the 2 away as a constant. So again, you get an indeterminate form, but when you're doing L'Hopital's rule, you do not necessarily have to stop after just using the rule once. You can use the rule again. So for this example, we're going to have to take the derivative of both the numerator and the denominator once again. So the derivative of 2x is 2, and once again, the derivative of e to the x is e to the x. So we can rewrite our limit as x approaches infinity for 2 over e to the x. And this time when you evaluate, you end up having 2 over the e to the x, and then when you plug in your infinity here for x, you end up getting 2 over e to the infinity, which is the same as 2 over infinity. Now, when you're dividing a constant by something that's huge, you ultimately end up getting 0. So overall, when you have an indeterminate form, you will be using L'Hopital's rule to differentiate the numerator and the denominator, and then you will be re-evaluating your limit. Thank you for watching.